Hey everybody, it's Ben again. I am attempting to record a video for the differential equations class concerning how to solve first order linear differential equations. As you might guess from my voice, I have had a couple of attempts already. So let's see if this one works. We're going to take a look here on the iPad screen at the general formulation of how we tackle these. So our first order linear problems, the essential notion of what you've got appearing here is that you've got a y prime plus p of ty equals this q of t. Now, it may not appear exactly like that, but you can put it into that shape. Please remember, if you have a coefficient of y prime, you need to divide by it, okay? We need to have a coefficient of y prime being 1 before we start. Otherwise, everything I'm going to say is completely invalid. And it's just because you have to get it into the right form before we can go. So from that form, we're going to pick out the p of t that's sitting here, and we're going to form something that's referred to as an integrating factor over here. The integrating factor is just a function that you get by taking e to the integral of that p of t dt, okay? Hopefully that integral will be something that's relatively easy to integrate, and hopefully it's something that when you exponentiate it, you get something back that's relatively nice. So the reason that we want that mu is that if we were to set up here the this setup here of mu times y, the quantity prime, and apply the product rule to that, then what we should get will be a mu times y prime, and then a y times the derivative of mu. But because we designed our mu to be nice, its derivative will be mu and then p of t, okay? So once you've got that, you can just multiply through the whole equation, and the left-hand side will become nice. The right-hand side, maybe not so nice, okay? But let's look at a quick example here that does something along these lines. How about y prime minus 2 over ty is equal to, let's just say like t, let's just say t, okay? So our p of t is going to be this piece here, the not just 2t, but the minus 2t. So when you get your integrating factor, you've got e to the integral minus 2 over t dt. So that's e to the minus 2 log t. But that means that you've really got t to the minus 2 power, okay? I skipped a little bit in that, but so that means that our left-hand side over here, we've got t to the minus 2 y prime minus 2 over t times that t to the minus 2 y equals, and then over here on this side, t times t to the minus 2. Now the left-hand side, you don't have to do algebra or anything here. We designed the left-hand side to get us what we wanted. It'll be t to the minus 2y quantity prime is equal to, on the right-hand side, it's going to be either t to the minus 1 or 1 over t. However you prefer to write it, doesn't matter that much, okay? So then we're going to integrate with respect to t on both sides of this. The left-hand side was designed to be easy. It is t to the minus 2y. And the right-hand side is pretty easy because we just got through doing it a minute ago. Log t, technically I should put the absolute value of signs there, but if I forget it, it's not that big of a deal. Then when you divide out, you end up with t squared log t plus c t squared. And that is, in general, what we have to do on these. The integration may turn out to be a little bit harder than that, but you know, some problems are harder than others. Okay, then let me take a look at another example that I jotted down here. And this one is fairly challenging. I don't want to be discouraging about that, but I had a teacher when I was a student who would always do all these easy examples and give us hard examples. I don't want to be that guy, all right? So here is where we're going with this. And yeah, okay. And so the problem we're going to have here is going to have y prime minus 2y equals sine 3t. And so when we tackle this, again, we pull out that minus 2, and your mu is going to be e to the minus 2t. Hopefully that wasn't, moving too fast there, right? And then we'll have our left-hand side, I guess I should write, as quantity e to the minus 2t, y, quantity prime. And then the right-hand side, which is what we're going to have to integrate, is e to the minus 2t sine 3t. Okay? So when we get to that part there, we have something that we need to integrate that's hard to integrate, right? So the thing that I do, because I use my resources, is I'm going to look over here at the formulas that I have from my old calculus book. And it looks as though formula number 19 is what we need there. See how it's an integral e to the au sine bu du? All right, so keeping that in mind, we're going to swap back over here, and I'm going to jot down what that formula said. It was integral e to the au sine bu du equals e to the au over a squared plus b squared times a sine bu minus b cosine bu, and then plus c, okay? So we've got to apply that, and we have to remember that our a is minus 2 and our b is 3. But we're really just writing down a formula because we only have to integrate this left-hand side here. Integrating the, I said left, I meant right. Integrating the left-hand side is super easy, and you just have the e to the minus 2ty on it. But the right-hand side, then we have to look over at our formula that we've got here. All right, so it says e to the au, so that'll be the e to the minus 2t, divided by a squared plus b squared, so minus 2 and 3, so we'll end up with a 13 there, and then an a sine bu, and so that's going to be minus 2 sine 3t, and then minus b was 3, and cosine 3t, and of course our plus c out there, all right? So when we divide the e to the minus 2t out there, we'll end up with a y equals 1/13 times this negative 2 sine 3t minus 3 cosine of 3t, and plus c e to the positive 2t, okay? And so if you would like to, then you can put the minus 2/13 sine 3t there, and the minus 3/13 cosine 3t there, and plus c e to the 2t. And you just leave it like that, okay? I'm sure in a similar example, if Don were working this out, he would probably look at this stuff here and say, aha, I'm going to do phase angle stuff. If you want to, you can totally do the phase angle stuff, but I'm going to kind of leave that to you if you want to do it. All right. So one more quick example. This time we're going to get an initial value problem, and it goes cosine t y prime plus sine t y is equal to cosecant t plus cosine t. And our initial value we're given is y of 0 equals the square root of 2. Okay? So one thing we may find, we may end up wanting to actually solve for our c before we actually finish it, because sometimes it gets to be a pain if we don't. All right, first thing is to divide. So y prime plus tangent t y is equal to, let's see, cosecant divided by cosine. That's not anything nice. So we'll just say cosecant t and secant t. And then plus cosine over cosine is just 1, okay? So our integrating factor is going to be an e to the integral tan t dt, okay? Integral of tangent, let's see, that is going to be the logarithm, should be an absolute value, but we're probably going to just drop the absolute values here, cosine t. And so that means that we will end up with just cosine t. Actually, you know what? I'm super nervous about that, so I'm going to jump back over here and check. Oh, it's a good thing I checked. Notice formula number 11, it was secant t, not cosine t. So that means that I need to come in here and fix that part, and then put it back for some reason. Okay, so logarithm of secant t, and so we end up with just a plain secant t there. All right. Now, once we've got that, we're going to multiply it through on everything, and the left-hand side will just turn into secant t y quantity prime. If you want to go ahead and write the extra step, go ahead and write the extra step, okay? But then the right-hand side, we're going to multiply through by secant t, and so we will have cosecant t secant squared t, that's weird, and then plus secant t, right? So the left-hand side, easy to integrate, but the right-hand side may be a little trickier. So I'm just going to write down secant ty here. And over here, I'm going to write integral cosecant t secant squared t plus secant t. Okay. Now that cosecant t secant squared, I think that the trick we need on that is to remember that secant squared is really 1 plus tan squared t. Okay, that's something that we're supposed to remember from trigonometry, but I know we don't always remember it. So if you've forgotten it, it's not that big of a deal. Okay, so now we're integrating cosecant t plus, now cosecant t is 1 over sine. So when you multiply cosecant t by tan squared, it will have something to cancel out. So integral cosecant t plus see, one of those. So that'll leave me with a tan t and a secant t, which has a nice integral. Okay, so then we've got that integral of the cosecant. I'm going to do it again and look over here. Integral of the cosecant is down here at the bottom. It is cosecant minus cotangent. So that's formula 14. And then we're going to have to integrate secant, which is log of secant plus tangent. So help me remember those as we go along here. That was one of the silliest things I've ever said. All right. We said cosecant t minus cotangent t, I believe. Check back here. Cosecant minus cotangent. Yep. I remembered right. And then plus the integral of tangent secant is just secant. And then plus the logarithm absolute value secant t plus tangent t. And of course, plus c. That is a horrible mess, but it's what we're working with. Now remember that your left-hand side there had secant t times y. So when we divide out and find y, we're going to have, let's see, divide by secant means multiply by cosine t. And then the logarithms, let's go ahead and combine them and have cosecant t minus cotangent t and secant t plus tangent t. And then plus, and that secant t, when we divide it out, we get 1, and plus c times cosine t. Yucko. All right, now we have to go all the way back up to the top and remember our initial condition had y of 0 equals square root of 2. So square root of 2 equals y of 0. Okay, cosine of 0 is 1 times the logarithm absolute value. The cosecant of 0 is undefined, and so is the cotangent of 0. And in fact, those are going to cancel each other out in the limit. Sorry, I am skimping over that one a little bit. But then times the absolute value, the secant of 0 is 1, tangent of 0 is 0, plus 1 plus c times, and we said the cosine of 0 was 1. So square root of 2 equals 1 times the log of 1 is 0, plus 1 plus c, and that says that the c is going to be equal to the square root of 2 and minus 1. So going back here to write it out, cosine t log absolute cosecant t minus cotangent t absolute secant t plus tangent t. I would wager that there is some way to take the stuff that's inside of that logarithm and make it simpler. But I don't spot how to do it just now. So we come down to that as an answer. And that is what I refer to as being pretty darn nasty. Okay. The examples that y'all are working on will involve you having to do some integration, but it shouldn't be that bad. Okay. I like to try to work some nasty examples so that you realize, yeah, we can get through them, but I try not to assign too many really bad ones to y'all. Okay. All right. So that's a couple of examples to get you going. And so have that.